All right, so we into chapter 15.5, which is our properties of logarithms. All right, and so in this chapter, we're going to talk about three important properties of our logarithms, which is our product property, our quotient property, and our power property. All right, so like always, you have this tip sheet available. On this tip sheet, I put, examples so that you can have something that you can look back on. All right, and this is probably the most important part of the tip sheet. All right, just making sure you don't incorrectly evaluate your logarithms, but you do understand what the properties are actually saying. All right, so as we get over here to the PowerPoint and take a look, we're going to have a slew of objectives for this section, but we're going to split this up in a couple. So we're going to do the first three in this first video. We're going to use the product rule for logarithms to simplify logarithmic expressions. We're going to do the same thing with the quotient rule as well as the power rule. And then lastly, we will use the rules for logarithms to expand logarithmic expressions and to write expanded forms to a single log. All right, so just a couple of things to remember when we're dealing with logarithms, right? It's still the same thing. It's basically saying 10 to what power will give you 2, right? And of course, this is rounded. That's what the squiggly line is for. It means approximately 0.3010. So if you just typed in your calculator, 10 to the 0.3010 power, you're going to be really, really close to 2. All right, and you see as we get up to 6, the decimal keeps getting bigger because we know that 10 to the first power is 10. So even if we went log base 10 to, and the argument was 9, it's still going to be, really, really, really close to 1, but not quite 1. All right, so basically, what does the product rule for logarithms say? It basically says when you have the product of a term, you can split this term, you can factor this term out and add it together, and you still should get the same solution. All right, so let's look at an example. In this first example, we should be able to figure this out without even doing the product rule, simply because we're trying to figure out, how can we simplify this? Well, we're basically saying that log base 10 of 1,000 equals x, which we're really saying, if we write this exponentially, 10 to the x power equals 1,000, right? Which hopefully we know our bases of 10, especially for you guys that's going into the sciences, which this is just, scientific notation. So we know that 10 to the third power is 1,000. So our solution for this is going to be 3. So what does our product rule say? So our product rule says that if we take 1,000 and break it into its factors, so factors of 1,000, so we got 1 times 1,000, 2 times 500, it's not divisible by 3, but 4 times 250, 5 times 200, right? So on and so forth. Any of these, if we break this out to log base 10 of 2 plus log base 10 of 500, these all should spit out 3, right? Because that's what our product rule says. So let's look at one. Let's just break it down. So let's just say 10 times 100 is 1,000, right? So if we say log, well, first let me turn it on. So if we say log of 10, which is just 1 anyway, right, plus the log of 100, which is just 2 anyway, right, we know that we get 3. Easier one, right, because we got base 10 and we have an argument of 10. But if we say log base 10 of 4 plus log base 10 of 250, 4 times 250 is still 10,000, or 8,000, right? So we still get 3, right? And it doesn't matter which one of these combinations we break this down to. All right, so again, this is our product rule. Okay, so same thing with log base 10 of 30, right? Think of our factors of 30, right? So factors of 30, 1 times 30, 2 times 15, 3 times 10, and what, 5 times 6, right? So any of these combinations will give us the same result that we will receive when we break this down, right? Because we're basically saying 10 to the x equals 30. X is approximately what? Right? So what is x? How do we break this down? Well, we can say if we use this 10 one right here, right? Because we already had a solution for log base 10 to 3. So if we break this down to log, let's say if I have a calculator and I broke this down to log base 10 of 3 plus log base 10 of 10. Well, I know that if my base is the same as my argument, this is 1 plus, right? And if I just go back to the beginning, we said log base of 3 is roughly 0.4771. Therefore, this is just 1 plus 0.4471, which is approximately 1.4471, right? This should be my answer. So if I just go to my calculator and double check it, log base 10 of 30 equals 1.4771, right? If I broke this down, log base 10 of 5 plus log base 10 of 6. 5 times 6 is still 30. Therefore, its summation is going to be the same, right? And so see, and we can, and it's the same thing, right? So that you can get practice on doing it with more factors of 30. All right, so our quotient rule, it basically says when we have the quotient of a term or the quotient of terms, I'm just going to take the log base, right, same base of the numerator minus the log base of the denominator, right? And so basically this is going to equal the same thing. And so if we start off with log base 10 of 1 over 2, well, again, if I just follow my properties from the last chapter, right, log base 10 of 1 is what? Log base 10 of 1 is 0, right? Because 10 to the 0 power is going to give me 1 minus the log base 10 of 2, which we just said, that's another one. We have the approximation on the front sheet. We just said that that is 0.3010, right? So just being able to do this without using the calculator yet, just so we can see this. So we said that that was minus 0.3010. So this is approximately negative 0.3010, right? So if I plug that into my calculator, log base 10 of 1 divided by 2, I get negative 0.3010, right? And so that would be the same if I said log base 10 of 1 minus log base 10 of 2, right? I'm getting the same answer. Alright, so hopefully you're looking at these and you're saying to yourself, okay, these are not as tough as they're made out to be, right? So again, if I go ahead and follow my quotient rule, I basically have log base 2 argument 1 minus log base 2 argument 8, which log base 2 argument 1 is just 0. And then just look at this and let's talk about our manipulating again, right? So can we do anything to this 8 if we think about it? So can we put 8 into a base and raise it to a power and still get 8? You bet. 2 to the third power is also 8, right? Which if I change this to 2 to the third power, I can go back to my base, my rules of logs that says if my base is the same as my argument, right, I can cancel the log. So this is basically minus 3. So my solution is negative 3. So log base 2 argument 1/8, it is going to be negative 3. right? And of course, we go over to our calculator, and so first I'm going to expand it, then I'm going to put the log into the other calculator where I can change the base. So we said log, oh, I can't even expand it because I got to go to the other calculator. Oh, which I already had it up here. Log base 2 argument 1/8 equals a -3, right? And so again, if you don't have a calculator that can change the base, right, you will not be able, well, you can write this out exponentially, which is just a whole different monster, right? But we can figure this out without even using the calculator, just by following our log properties. All right, so log base 10, now we're back to 10, which now we can utilize our calculator. So anytime we get log base 10 of 15 divided by 2, so it's basically, I can break out this, I can use my product rule with 15, because I can say log base 10 of 3 plus log base 10 of 5 minus log base 10 of 2, right? And some of you guys are probably saying, what do I need to do this? Trust me, like I keep telling you guys, if you're going into the sciences, this is going to make so much more sense when you get there with this understanding of your logs. Okay, so when I'm looking at this, right, I can just plug this right into my calculator. I can say log base 10 of 15 divided by 2, and I get 0.8751, right? Or I can say log base 10 of 15 minus log base 10 of 2, and I get 0.87501. Or I can say log base 10 of 3 plus log base 10 of 5 minus log base 10 of 2, and I still get the exact same answer, right? It's just by utilizing those different properties. All right. Lastly, the property we're going to look at is our power property, which basically says if your argument is raised to a power, the power just comes out in front of the exponent. All right, now notice my base is different than the argument. Now, if my base is the same as the argument, then my solution is just the power. Okay, so let's not get those mixed up. All right, so if I'm looking at log base 10 to the square root of 2, right? Remember how we can rewrite this radical form exponentially. So this becomes log base 10 argument 2 to the 1/2, right? Well, this is basically 1/2 log base 10 to the power of 2, which we already said this was approximately 0.3010, and now we're just going to take half of that, which is approximately 0.1505, right? That should be our answer. So just by utilizing the tools that we already know, we don't have to go to a calculator to evaluate this, but of course we always want to use our calculator just to verify, right? So log base 10 radical 2 is going to give us 0.1505, which is the same as 1 divided by 2 log of 2, 0.1505, which is the same as 0.5 log base 2, or log base 10 argument 2, 0.1505. All right, so again, hopefully you're looking at this and you're saying, okay, this is making a little sense. Okay, so again, we have this log base 10 8, and you're probably saying, well, how does my power rule apply to this? So remember how we broke the 8 down last time? We can do the same thing. So log base 10 argument 2 to the third equals 3 times log base 10 to the second, right? Which again we said is 0.3010 approximately, and now we're just going to multiply that by 3. All right, so basically 30% of 3, right? So we go to our calculator, 3 log base 10 of 2 gives us roughly 0.9031, which is the same as log base 10 of 8, 0.9031. Alright, so hopefully, these are making sense to us. And so I'm going to end here, right? I'm going to let you guys look at this. I'm going to give you a couple of minutes to just look at it. But I want you to figure out what is the solution of this. And then when we come back to the next video, we will start off here to see if you figured that out. Alright, talk to you soon.